Hello, welcome to the fourth video of ymfc-mini-drone. In this video, I will talk about how to use the board as a flight controller to control brushless motors and install it on a F450 frame. Firstly, we need to modify some code. We need to change PWM outputs back to original value. In the flight controller firmware, the lines are at 315 to 317, but the code related to battery voltage don't need to be changed because this part won't be useful anyway. I will explain it later on. Similarly, we should modify the testing firmware. The changes are in check motor vibrations and timer setup. Since in testing firmware, we are directly feeding channel 3 input from receiver to PWM outputs, there will be some differences. But experimenting with code, you will figure out why it's written in this way. Let's first remove the 3.7 volt battery. The RX2A will be replaced by another PPM receiver. Now we can remove the mini propellers. The motor wires are soldered on the board. We need soldering iron to disconnect them. Then we can remove the motors. To output the PWM signal to ESC, we need 4 additional PWM output ports. They are all 3-pin headers. It's time to connect the board to the hardware on F450. We need to connect BAT port, receiver port, to connect with IA6B receiver and 4 PWM output ports. I also designed 4 screw holes to fix it on the frame. I'm using FSIA6B as receiver. Its pin sequence from top down is PPM signal, power, and ground. You can use a 3-pin wire to connect it on the flight controller. I'm feeding the BAT port with the 5V output from UBEC. I can't directly feed 12V to that port, otherwise it will burn the radio receiver. So the measurement result will always be a constant 5V and not useful to compensate voltage drop or send a low battery alarm. The rest ports to connect are PWM outputs. I labeled S for the signal pin. The pin in the middle isn't used, and the other pin is GND. Let's give it a test. Plug in the 12V power first. It provides power for the UBEC. Receiver will be enabled if we turn on the power switch. Now let's plug in the CP2102. The ESC is constantly beeping because it's powered on and it hasn't received PWM signal yet. The LED and IMU hardware remains the same, hence no need to test. Voltage measurements is useless, so no test either. What we need to test is the receiver and ESC. That's why we need to power on the 12V instead of just using 5V from CP2102. Let's plug the CP2102 to the computer. Make sure STM32 is in firmware downloading mode. Then download the firmware. Unplug the J1 jumper and reset to normal mode. Open the serial monitor. If nothing shows up, you can hit the reset button again. Some text shows up now. It says no receiver signal and ESC are disabled. Now we switch on the power button and open the radio transmitter. If you use the transmitter to control multiple receivers, you need to choose the correct one. Once connected, you will notice the change on transmitter screen and receiver LED. If we hit reset button again, you will see that motors are enabled. Now we can test receiver signal. Make sure all movements correspond to correct result in the serial monitor. And you can try to send arm or disarm command. You can input 1, 2, 3, 4 to test each motors in serial monitor. Command Q is to quit current test. Normally, if you raise throttle in the transmitter, motors will spin. If some motor doesn't spin, you should check connection. You need to make sure all 4 motors can spin, and they are in the correct position according to the text on serial monitor. Command 5 is to send PWM signal to all motors. If you increase throttle, all 4 motors would spin. This is useful for ESC calibration. It's important especially if your ESCs are newly bought. It guarantees motors spin at the same speed and the same PWM signal. I firstly unplug 12-volt battery while all motors are at their top speed, so all PWM outputs should remain 2000 microseconds, since the flight controller board is still powered by USB. After that, replug the 12-volt battery, and all ESC will be powered on and in ESC calibration mode. Then I can decrease the throttle and increase the throttle again to finish the calibration procedure. This is an easy method which is valid only for my ESC. Your ESC might be different. Please refer to the manual of your ESC. You might need to connect a PWM receiver directly to ESC for calibration. The last thing to do is balancing propellers. You need to install propellers individually. The result in serial monitor is the current vibration. You can stick electrical tape on one side of the propeller and try to minimize its vibration while rotating. After all tests and refinements are done, we can now download the flight controller firmware. After download, you will see blue LED flashing. Let's unplug CP2102 J1 jumper and give it a power cycle to make it permanent. You can turn on the transmitter and unlock the drone. Now it's ready to fly. Thanks for watching.